Hey there, I'm Anca Constantin. I'm professor of physics and astronomy at James Madison University, and when I'm not in a classroom, I am in my office, drinking tea and eating chocolates, of course. That is while I am doing my research on so my investigations are pushing the frontier of what we know about galaxy centers, in particular about those galaxies that have actively accreting supermassive black holes in their centers. Therefore, their names, active galactic nuclei, or AGN, just in case you hear about them somewhere now, you know what they are. So they're believed to be the energetic manifestation of a black hole that is as massive as millions to billions of times the mass of the sun, that is actively accreting of matter, all kinds of things, gas, stars, onto it. And it's through that swirling motion and the friction between those particles that they heat up at tremendously high temperatures and emit the light that we see. You probably heard about quasars. Those are the most luminous manifestation of these galaxy centers. And so with my students, I am studying their properties. We're trying to understand the relationship between the black hole and what it's doing with the host galaxy, kind of trying to answer this question very similar to the chicken and the egg, like which one was first, the supermassive black hole or the galaxy? Like how basically learning how the galaxies were formed, how the galaxies evolved, trying to understand how many supermassive black holes are out there. Are they all big, small? How big? How do we weigh them? How do we find them? Are they hidden by veils of dust? There are so many questions that we can address with data that is obtained across the whole electromagnetic spectrum. My students work, or as they say, they're locked up in the lair, the Laboratory for Astronomical Image Reduction. Get it? They're all done. It's snow day, I suppose, but they work so hard. Look at them. They're all showing off their work. Lots of data analysis happening here. We do have a lot of data across the whole electromagnetic spectrum because that matter that swirls around the supermassive black hole that emits from gamma ray to X-ray to visible, infrared, and radio, and each of them are able to tackle quite a variety of properties. Hey, Sloan is actually writing her senior thesis on a particular type of activity that happens in galaxy centers. It's a laser that emits in microwave, and so that L is replaced with an M, and so she would proudly tell you about the maser work that she's doing. These masers are amazing. They have a disc-like geometry that allow us to measure distances to the galaxies in which we detect them. So just a side note, think about measuring distances like in your everyday life. It's doable, it's possible. You take the meter stick and go and measure stuff. Well, we can't do that with the sun, but we don't even talk about the sun. We talk about distances that go outside our own galaxy. And the masers, if we find them in that particular configuration, are able to allow us to measure distances to faraway stuff and like galaxies, obviously, and that is going to allow us to put new constraints on the current models of the geometry of the universe. Not even talking about how that disk of masers around the supermassive black hole is actually the best tool we have so far in weighing and finding out just how much mass is in that supermassive black hole that keeps things together. I wanted to tell you about another beautiful piece of work that my student Jenna found. She was part of the discovery of a triple AGN supermassive black hole system. So 3 galaxies interacting, and we did find out that one of them, the 3 of those centers of galaxies, they were actively accreting gas around them, and she did that through spectroscopy with the large binocular telescope. She was the one reducing the data and measuring the broad emission, the squiggles like this. She learned how to do that and found out that the gas that was observed in near infrared was rotating at speeds really close to the speed of light, and there's nothing else out there that can explain that kind of motion but the gravitational pull of a supermassive black hole. So amazing stuff happen in this lab when you're looking for ways of finding supermassive black holes. Okay, time to go back to work. Now where's my chocolate? Looks like it's all gone. Must have been a lot of grading lately. So yeah, even more of other things to do. So anyway, you wanna find out more about how supermassive black holes work in galaxy centers? Come and visit us. We have our corridors here adorned with the posters that our students put together based on the work they do with me or other faculty members. Bye.